We think many viewers are generally concerned with tunnel or underground systems, so what are the boring companies' measures to deal with emergency issues?
Yeah, so I think purely from a safety perspective, there are some quite problematic risks when operating on the lunar surface. It's not just applicable to tunnels. Obviously, even just building your lunar base is going to be a time-consuming and difficult process if you want to do it safely, and we definitely do want to do it as safely as is feasible. What I will say is that safety is paramount. You put number one importance on safety at all times. It's not quite as risky as you might think it is to bore tunnels, because all those processes that you're going to utilize under the lunar surface are going to be very, very similar to the ones that you use under the Earth. So in that regard, the risks are fairly manageable, really. You're obviously going to do a full risk assessment of all the work that you need to do, and I'm sure SpaceX will do that, but you need to think about everything that goes on prior to the tunnel boring machine arriving, and also during its operation, not just underground but at the surface as well, because there are various activities that you're going to need to do to support the construction of your tunnel underground. So one thing that is quite risky is going to be connecting up your power supply for your TBM. You're going to have to run a power supply from your power plant, whether it be some kind of nuclear power plant or large solar array. That's going to have to be run across the lunar surface. It's going to have to be protected. You're probably going to do it with equipment and manpower. So again, obviously, you're exposed to the elements there. That's potentially quite risky, and you're going to probably do that in various stages at various times of the day. So again, you need to do a full risk assessment and establish how you can do that safely, whilst also minimizing risk. Whilst that's going on, you're probably going to be assembling your TBM, which is going to arrive in and around 60, 70 different pieces, maybe more. That work is going to take place in a sort of enclosed, pressurized work zone. That work zone is going to be very secure. People are still going to be suited and booted, they're going to be protected, but that area is going to be worked in a safe pressure, and it's also going to be a safe temperature. So again, that reduces a lot of the risks in that area, but it is a confined space. There are potentially risks when you have very, very heavy components, which you're going to be lifting and assembling at various stages. Obviously, when you're lifting something that is very heavy, even on the moon, potentially there is the risk that thing could fall and injure operatives. So you're going to have some kind of lifting plan, and you're going to do it in stages. How you do that is dependent on what that component is and its weight. You may have a small jib crane, or you may want to go for something that is well known for being very safe, like a gantry crane. So a gantry crane could be assembled fairly easily. Obviously, you're going to have to ship those components, but it has the added bonus of it being extremely safe, and it can support most loads. So you want to do it as such. Operating the TBMs, once you've assembled your TBM and you've commissioned it and you go to work, actually operating that TBM is going to be very, very safe. TBMs have been used for 80, 90 years, maybe longer, and they are very well-known pieces of equipment. The fact that they operate underground might seem dangerous, but when you're operating on the moon, being underground actually is a bonus, because you can pressurize part of that area, and you can have an area where people can be sat operating the machine safely, and there's no risk to them tearing their suits, or falling down and injuring themselves, or being caught in a piece of equipment. So you can isolate people away from the actual processes, and thus it becomes a lot safer. A good addition to proof rock would be gripper shoes. Gripper shoes are very useful, large hydraulic rams. That allows you to remove the cutter head away from the face of the excavation. For example, if your cutter head becomes stuck or jammed into that face, rather than going in there and putting yourself at extreme risk, you can actually remove the cutter head back from the face, allow it to partially collapse, and then you can excavate that spoil in a much safer sequential manner. So that's a good addition that's going to make things a bit safer for us. Operating in a crater, obviously, on the lunar surface is going to be a massive bonus. You obviously start off much lower down. You're probably going to avoid going into other craters and potentially exposing the tunnel to the external temperatures and pressures and things like that. So if you can start in a crater and then you start in a launch pit that's around sort of 10 to 20 meters deep, that's going to be extremely useful to you. And obviously the craters have lots of resources in there, so that's going to also help you in your search for various things. So really all the kind of risks that you can kind of think of in terms of the tunnel collapsing or being exposed to the surface or accidents occurring inside the TBM, they're pretty much been minimized and reduced to levels that probably just as safe as on Earth, really. So you could really, if you are very concerned about safety, you could have some kind of refuge point inside the TBM just in case something does happen. But the reality is that these machines are going to be autonomous. They're going to be controlled via algorithms. They're going to be operated in a very kind of simplistic and very kind of straightforward manner. So the TBM is going to go mainly in a straight line, very small radius on any kind of curves. It's going to be mostly straight. It's going to be going downwards at a very low gradient. So really the kind of complexities and risks are going to be eliminated on these kinds of projects. So all in all, very safe. In terms of spoil removal as well, you're going to remove that into some kind of crater somewhere, some kind of spoil heap on the surface. Again, that can be automated. You can have your trucks as they were. Dumper trucks could be fully automated, and you can have them coming in and out every sort of couple of hours, which is is going to be fine. So I think all in all, when you look at the entire process, it's very safe, and my concerns are quite minimal if you think about things and you plan ahead with a proper risk assessment. So very safe.
So to recap, the third and current generation of TBM, Proof Rock, is the key to drilling extremely useful tunnels on the moon. But how easily can Proof Rock be transported to and assembled on the lunar surface? And over what kind of timeline?
Yeah, so there's a great deal of complexity when it comes to moving a very heavy piece of machinery like a tunnel boring machine from the Earth to the lunar surface. Obviously these tunnel boring machines are extremely heavy. They can be broken down into the constituent components. However, again, those are still going to be quite heavy. So most parts of a TBM are going to be less than 20 tons. So they're going to be reasonably easy to transport to the moon. However, there are certain components that are going to be a little bit more complex. So the cutter head, the bearing support, and the back end of the machine are going to be above 45-50 tons, in that kind of ballpark, even if you modify those components so they are lighter, so that you can ship them to the moon. I think the only means that you can do this is via Starship. I don't see any other viable alternatives for that at the moment. So if you're going to use Starship and you're going to leave a margin for error, you're going to need maybe around 7 journeys to transport Proof Rock, including all the equipment you need to assemble Proof Rock to the lunar surface. The assembly of that machine is reasonably easy. Obviously, you're going to have your pressurized work zone where you're going to have your operatives in there. It's going to be assembled piece by piece using existing methods, and there's no reason to change that, and that's going to be a reasonably easy process if you have people that are familiar with the assembly of TBMs. If anything, it should be a little bit easier because those components will be lighter on the moon. They'll be easier to move around, especially some of the very, very heavy parts like the cutter head and the bearing supports. Obviously, you're still going to require some equipment to assemble that tunnel boring machine. So you'll need either some kind of jib crane or maybe a gantry crane. Obviously, I prefer gantry crane because I think it's a bit more, a bit easier to use, and potentially it's going to speed up the process of assembly. Something potentially that you could use is some kind of robotic exoskeleton or a mechanized suit. Obviously, you're going to have operatives in and around TBM during its assembly. So if you could have them wearing those kinds of things, then ultimately they'll be able to pick up pieces they wouldn't be able to do on Earth and assemble them almost by hand, which is advantageous to your colony on the moon. You're talking in and around, if I'm going to be quite cautious, in and around 8 to 10 weeks to assemble your tunnel boring machine or proof rock. Obviously, that does not include the manufacturing construction of your pressurized work zone, which is essential to this. You need an area that's going to have a stable temperature and a stable pressure. It needs to be built in advance of the TBM arriving, and obviously those components are going to arrive. They're going to be stacked up, and then once you're ready to go, you pressurize the area and then you begin the assembly process. During that time, you can also be excavating your launch pit ready for your TBM. So all that work can occur concurrently. Most of these processes unfortunately can't be automated, or I don't currently see it being able to be automated. So you're going to need actual manpower on site with experience assembling these various components. Fortunately, a TBM it involves a lot of very big components, quite bulky components, so putting it together generally isn't as difficult as you would think it would be. So you're going to need a team of around 10, maybe 12 operatives to get this done. You're looking around maybe 10 weeks of work. So all in all, it's not an entirely difficult process, but there needs to be a bit of pre-planning done, and I think it's very, very viable and can be done economically and in good time. Absolutely.
And you told us that you even have an idea about digging tunnels without a boring machine in the early days of a moon colony. Could you elaborate on that?
Yeah, so there's many ways to bore a tunnel. I think during those initial years when you're setting up your base, your lunar base, and you're wanting to explore the strata below that base, you're probably going to do some trial tunnels. And the most convenient way of doing a trial tunnel is going to be something like a road header. Don't get me wrong, TBMs like Proof Rock are extremely useful pieces of equipment. However, they have advantages and disadvantages. One of the main advantages of a TBM is it is extremely safe to use. There have been very, very few fatalities inside TBMs. Very, very few, because they are ultra safe pieces of equipment. However, they're very bulky, complex, expensive pieces of equipment, and they ultimately are going to be difficult to move to the lunar surface. It's certainly possible, but there's going to be some complexities there. Another potential option in the short to medium term, so you're talking in the first sort of 5 to 7 years, is going to be something like a road header. Road headers are very, very capable pieces of equipment. They've been used to bore mining tunnels and road tunnels for the last 50 years. They're well understood. They're very compact and lightweight, super reliable. Another bonus is that current road headers are already autonomous. Currently, Proof Rock is what you'd consider maybe to be semi-autonomous. For that to operate on the lunar surface or below the lunar surface, you're going to need it to be fully autonomous. Road headers already do that. Very simple. They follow a trajectory. They have an excavation pattern, and they follow that within 1% of what it should be. So there's a lot of advantages to using a road header. They're going to be less than 30 tons, so it's going to be very easy to fit that inside a Starship. It can be maybe broken down into 2, 3, maybe even 4 individual components, and then reassembled on the lunar surface. A TBM, on the other hand, is going to probably involve maybe up to 60, maybe a bit more components. So it's going to be a lot easier to assemble. Potentially it could be shipped in one piece. Theoretically, it might be a bit easier to do it in multiple pieces, maybe 3 pieces. Another advantage of a road header is that on the lunar surface, that weight is not really applicable. There's obviously a lot less gravity on the moon. Therefore, your actual cutting mechanism potentially could be heavier than you have it on the Earth, and it also could rotate at a much higher rate, potentially up to 300 RPM. So you could increase the advancement rates significantly if you could speed up that cutting mechanism to a very rapid rate. I think we're talking around 7, maybe 8 meters per day of progress with a road header, which doesn't seem like much, but I think that's very, very useful to begin with. You could certainly dig a few trial tunnels, explore the ground, get an understanding of what you're working with, and then maybe at a later date, maybe in 5, 10, 15 years, you bring in your TBM, and you've got a better understanding, and your TBM can do the job for you. Road headers can also be used to excavate side shafts and cross passages, so you could still have a team of road headers on site, and they could do other jobs for you as well. So it's going to be a very useful piece of equipment for those people settling on the lunar surface. I think that it is definitely an option worth exploring, and I think once you have that data from the ground there about the strata, you could definitely then make a better decision in regards to bringing proof rock and adapting proof rock so it fits the ground conditions. So definitely would recommend using that as a potential option on the future lunar base.
And what kind of adjustments might be necessary to give proof rock the capability to operate on the Moon, Mars, or even Titan? Because Titan is probably the most fascinating moon in the solar system, and we know that there are many Titan lovers among the viewers of this channel here.
Yeah, so from an operational perspective, the way that a tunnel boring machine operates on the Moon or Mars or even Titan is going to be exactly the same as it does on Earth. It's going to use exactly the same processes to bore through the rock. The major kind of differences that we're going to see between proof rock on Earth and on other planets is going to be the weight of the various components. So the major components inside a TBM are going to have a weight reduction of around 20 to 30%. That is possible because the stresses and strains on other planets is going to be less because there is less gravity, which is a bonus. However, you still need to transport those components to the planet, so again that's an added cost, but weight reductions are going to help you reduce the overall transportation budget. One major kind of change that I think would be useful is replacing the thrust cylinders with a gripper shoes system. It reduces the complexity, it also increases the potential safety and enables somewhat continuous mining, although you're not really looking for extreme speed when you're operating in the mining sector. You're looking more for control and safety. Another major change is your segments or tunnel lining. That is going to change from concrete to either aluminium or an aluminium alloy or steel alloy, something along that lines, as that will enable weight reduction, enable you to ship much thinner segments and also reduce the diameter of the machine as well. Future TBMs I anticipate will be manufactured on the planet where they are based, whether that be the Moon or the Mars, or maybe even Titan. Titan will come a very long way into the future. I think that establishing mining operations on the Moon and on Mars will come much earlier, and the focus will be there for many decades. At some point there will be a push to go to Titan. I think that there's a great opportunity there to set up another colony or another base there, and again, the same things apply. If you've got reasonably good geology, if you've got a pressurized work zone, and if you have the capability of transporting very heavy pieces of equipment to Titan, then it's definitely possible. But if you're already based on Mars and there are humongous resources on Mars, you're probably going to stick to Mars, certainly for the short to medium term, before you start thinking about setting up your third base, as it were, on Titan. But it is exciting. I really hope that I'll be around when we do set up base on Titan, but I'm thinking probably not. But yeah, exciting times. It can be done. Tunnel boring machines can operate anywhere where there is rock and a reasonably stable kind of weather system.
By the way, if you missed our previous video on that topic and are curious about the applications of boring tunnels and TBMs on Mars, you can watch our last collaboration with Will. The link to the video is also in the description box down below. So previously we touched a bit about how comparatively easy it would be to build a Hyperloop network tunnel system on the Moon and how beneficial it would be. And as we know, there are already many Hyperloop projects going on here on Earth. So Will, why do we need both transportation systems, boring tunnels as well as Hyperloops?
Yeah, so I think the transportation industry is going to be very heavily disrupted over the next 15 to 20 years. Two of the major reasons for that are going to be the Boring Company loop system and the Hyperloop system. Although both systems cater for different markets, they do complement each other really well. And you definitely do need both systems, because what the Boring Company is going to do is they're going to build systems that cater for journeys of less than 100 miles. So you can move people at around 155 miles per hour in those systems, maybe slightly less. And for most people, most of the time, they're going to be conducting journeys of less than 100 miles. So for them, that is the perfect kind of system. Obviously, the aviation industry is going to be heavily disrupted via the Hyperloop. The Hyperloop is going to be moving people well over 600 miles per hour. Very long journeys ranging from 100 miles all the way up to maybe 8,000 miles. So they both operate in different markets, as it were. But when you arrive at your Hyperloop station, you're probably still going to be quite far away from your end destination, so you may then end up using a Boring Company loop pod for that remainder of your journey. So they both kind of operate together in unison, which is very good. I think overall, in terms of transportation, all systems that favour autonomous methods will benefit over the next sort of 15 to 20 years. So that goes to sort of trains and maglev, buses, and also VTOL as well. VTOL is certainly a system that is going to be very expansive over the next 15 to 20 years, most definitely. But the Hyperloop and the Boring Company loop system will dominate the transportation space in the near future.
Thank you so much for your insightful answer here, Will. And we think that we could all agree that the more transportation modes we have, the better it is. And another emerging new transportation technology is of course flying air taxis and Elon Musk's famous eVTOLs. The Chinese company Yihang already started their air taxi service in China. But there are many more companies working on such commercial urban air mobility projects. So maybe you could explain to our viewers how flying cars and boring tunnels will complement each other in order to drastically reduce urban congestion.
Yeah, absolutely. I think if there's that kind of interconnectability between the systems and they mesh together quite well, definitely there is a good use case for having VTOL systems and boring company tunnels interlinked in certain cities and suburbs and various other places, maybe island communities. So for journeys of less than 150 miles, I think VTOL is a really impressive and useful addition to the transportation space. Will work incredibly well in dense cities and also connecting small communities to the suburbs and central business districts. I think there'll be fairly regular interconnections between boring company stations and VTOL landing pads. Landing pads can be placed on the ground. They can also be placed on large multi-story buildings. This obviously improves the efficiency as well, because you're not having to come down to the ground. As battery technology improves, and it is improving at a very rapid pace, I suspect the argument for VTOL will improve dramatically. I think in less than 5 years' time, the prospect of VTOL systems with a range of possibly up to 200 miles, maybe 180 miles, that's going to be very, very possible and very economical as well. There's many impressive companies in this space, startup companies. Obviously, EHang, as you mentioned, is incredibly innovative. I'm very impressed with their product. Lilium as well, from Germany, they have a really great product. I've been very impressed with what they've been doing. And also Kitty Hawk in the USA, they've got a really great system as well. So there's definitely going to be a lot of competition in that space, and it's depends on how they innovate and how they improve the economics of flying these journeys. I think in somewhere like Europe, it could potentially capture up to 5 to 10% of all journeys by 2040, maybe earlier than that. So there is a big potential for VTOL in Europe, in North America, South America, and especially China as well. I think certainly in the suburbs and some isolated communities, VTOL could be a real benefit to the local economy. Obviously, there's not going to be Boeing company systems in those kinds of areas, so that's its own kind of use case for VTOL. So you've got very isolated places that are miles and miles away from really kind of dense communities. So that would be definitely quite a good use case, potentially some good money to be earned there by setting up local systems. As not all places can be linked via tunnel, it's just not economical to build a tunnel, even if it's just $5 million per mile. Profits and gross margins in those kinds of areas, because it is the number one choice for transport, could be exceedingly good, and there's definitely the potential there for a big market share for VTOL in the near future, and that's exciting, really exciting to hopefully see that in the future.
So Will, thank you so much for joining us today. We are absolutely inspired about the future potential of the Boring Company and about the future with Boring Company tunnels under every planetary settlement. A permanent base on the Moon is the logical first stepping stone for humanity to the solar system, and tunnels offer great utility to those bases on and below the lunar surface.
And be sure to check out Will's awesome YouTube channel, A Boring Revolution, where he shares weekly updates on all Boring Company projects. And consider supporting his work while patroning our other means. Ja, so genug Fähigkeiten. Ja, fertig.
Wann bist du mächtig?